All right, so our last section in chapter 7 is on graphing radical functions. So we're going to be graphing square root functions, cube root functions, etc. with and without a calculator. Your next quiz, which I think is on Tuesday of next week, because we're going to spend a lot of time on domain and range. Part of it will be calculator, part of it will be no calculator. So make sure you're not doing everything on your calculator on your homework. All right, so we have our quadratic function, and we have its inverse, which is a square root function. And we've seen these before, but you can see that the horizontal line test, they talk about working. So if you use the horizontal line test on the original function, remember that'll tell you that the inverse is actually a function or not. So that's a test you can use to determine if the inverse is a function. But I know a lot of you just like to do the vertical line test on the final answer. Now, to graph this without a calculator, you would create a table of values for each of them. You pick the numbers you want to plug in to the equation. So I picked a couple negatives and a couple positives, and so we would get 4, 1, 0, 1, 4. You can see that those are already plotted on here. Remember, the inverse, all it does is it switches the x's and y's. So we'd have 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. So just switch around the x and the y's. Now you will notice a pattern for the square root function. It starts at 0, 0. If it has no stretch or shrink, so no number in front of the x, it goes up 1 over 1, and then it goes up 1 over 3. That is a useful thing to remember if you're sketching the graph without a calculator, because then you won't have to do a table of values every time. We could come up with more points, but usually that's like all you're going to fit on the graph anyways, and you can just draw an arrow kind of going up. Okay. You'll see on the back, we're asked to graph some of these where they don't have any shrinks or stretches, so you can use this pattern to not have to do a table of values. All right, now this one had the positive and the negative because we have the square root. Now notice this one is half of a parabola. They give us a restriction on the domain. So they're telling us we're only looking at when x is greater than or equal to 0. I forgot to talk about the domain. So the domain in this one was given to us. What would the range be for this function? Caleb? Good. Y is greater than or equal to 0. Now notice when you take the inverse of this, you only have a positive square root, so it's only half of a parabola also. The domain and range here, again, are going to switch. But really, they kind of stay the same. And then this is one we have not looked at yet, and this is our cube root function. So we have g of x equals x cubed, which we did look at cubic functions themselves. So again, you can pick any points you want here. Some of these aren't going to fit on my graph, but so negative 2 cubed would be negative 8. Negative 1 cubed would be negative 1, 0, 1, and 8. So really you can see that they only fit 3 of those points on the actual graph. But a lot of times the cube root, when you change and add numbers or subtract numbers, remember they kind of look usually like this. They go up, down, and up again. But this is the parent function. So notice whenever it's switched sideways, it stays with our 0, 0. Again, all we're doing is we're switching these points around. The points themselves actually stay exactly the same that you plot. The only thing you have to remember to do is to draw the graph going sideways instead of up and down. Now let's talk about the domain and range for these. What would the domain of this original cubic function be? Sam? All row numbers. Goes left forever and right forever, and then range would be? Bobby? All row numbers too, because it goes up and down forever. So the domain and range of this one would be the same. Now, why do we not have a positive or negative right here? Garrett? Because it's cubed. So remember, when you take a cube root, the cube root of a positive number is positive, the cube root of a negative number will be negative. So you don't put a plus or minus. This tells us the inverse of functions in the form y equals x to the n power will be equal to y equals the nth root of x. So if it was x to the fourth, the inverse would be the fourth root, and so on and so forth. On the back, we're going to look at some transformations. These are all really similar to what we did with absolute values and with quadratics. So the shifting left, right, up, and down. All the rules are basically the same. So if you have a negative out front, that is a reflection across the x-axis. So this one would look like this. This one would look like this. Now, when you have the a value, whoops, it's real there. Anytime you see these are stretches or shrinks. So what that does is it's going to change like how the points differ from one another. So anytime you see an a value, you need to use a table of values. You cannot use our shortcut, which was our up 1 over 1, up 1 over 3 for the square roots. And then these ones you guys probably remember from our quadratics. They're all the same. They're just going to be the square roots. What would the negative 2 or the minus 2 tell me? Up 2, down 2, left 2, or right 2? Chapter 5. Up 2, down 2, left 2, or right? Garrett? Right 2. Remember, if it's inside, it's left or right, and it's the opposite direction that you think. Because normally, minus 2 would go to the left, so it goes to the right 2. And then the plus or minus outside tells you up or down, so this would be up 3. Those same transformation rules apply to square roots. So if you see a minus underneath the square root, that's going to be to the right. If you see a plus, you'll go to the left. Outside, this plus k would tell me to go up. And then you can also have a combination where you're doing both, like moving to the right and up, or moving to the left and down. Now, all of these below could be done using a table of values, but again, since we learned the shortcut for a square root function, which is to start at 0, 0, and then we usually will go up 1 over 1, and then up 1 over 3. As long as there's no stretch or shrink, you can use that shortcut to graph these rather quickly. Now, we will have to take into account that we have some shifting. So we're graphing 2 on the same graph. So I'll graph this one in blue. This one is telling me to go up 5. So you're taking the whole graph and shifting it up 5 units. So you really just have to take the starting point and shift it up 5 units. So 0, 0 is where you normally start, go up 5, and put a point. And then you still use your pattern, up 1 over 1, up 1 over 3. And then you'll just connect that to create a nice little sideways parabola. I call it like a shooting star. It's like it's going off in one direction. All right, now the next one says minus 7, which tells me that this is going to get shifted down 7 units. So again, starting at 0, 0, down to negative 7. And then we will use our pattern, which is up 1 over 1 and up 1 over 3. It would not continue to go up 1 over 3, up 1 over 3. It would have a different rate of change after that, but you just need these first 3 points to be able to get a sketch. All right, see if you guys can try the next one. Graphing both of those. Actually, try 2 and 3. We're going to skip 4. And then this one should have gone to our right. 5. So this would be, and you might not be able to fit the whole thing on here. Something like that. Make sure you do have an arrow on the end and that you do draw it to the edge of the graph, so showing that it goes on continuously. We'll skip number 4. On the next page we have some combination graphs. Okay. So again, for our combined transformation, A, the number outside represents a vertical stretch or a shrink. And if you have a negative, that will indicate that it's been reflected downward across the x-axis. Now, notice that all of these have A values. Okay. I would suggest a table of values for the A values. You can sometimes observe that instead of going up 1 over 3, you're going to go, or up 1 over 1, you're going to go up 3 and over 1. But sometimes, especially if there's a number that goes inside here, that will change it again. So anytime you see an A, I suggest a table of values. You can't go wrong with it. And then we will check this one on our graphing calculator. Again, you don't know what numbers to plug in, right? I don't know what to pick, but I'm going to start with, again, maybe -2. Because when I plug in -2 plus 2, I'm going to get 0, and then I know what the square root of 0 is. Okay, so I'll do this by hand. -2 plus 2 is 0, the square root of 0 is 0, 0 times 3 is 0, and 0 minus 1 will get me -1. Let's try -1. -1 plus 2 is 1. So I'll get 3 minus 1, which will get me 2. Now if you choose 0, 0 plus 2 is 2. You're going to end up getting 3 square roots of 2 minus 1, which I don't know what that is without a calculator. So I'm probably not going to plot that point, right? If I plug in 1, 1 plus 2 is 3, I'm going to get the square root of 3. I don't know what that is. But maybe I'll try plugging in positive 2, because positive 2 plus 2 is 4. The square root of 4 is 2, and 3 times 2 is 6. 6 minus 1 is 5. So sometimes you have to kind of play around in your head and think of what numbers will actually give me a square root I know. Because this one I can't plot, right? So then we'll go ahead and graph this. So -2, -1, -1, 2. And they do ask us this time for the domain and range of the functions as well. What is the domain of the function? You can either look at the graph, or you can do it algebraically looking at the numbers. Abby? Good. X is greater than or equal to -2. Remember, domain is your x-axis, so the smallest it ever gets is -2, and then it goes up to infinity. And then our range, the smallest it ever gets is -1, and then goes higher. So y is greater than or equal to -1. All right, next one, we have a shrink, which means that instead of getting steeper, it's actually going to get flatter. Again, I would suggest a table of values. What do you think a good number to plug in would be so that I can take the square root of the values? You can think of a good number to start with. Abby? 3? Sure. So plugging in 3. 3 minus 2 is 1. The square root of 1 is 1. I get 1/4 minus 4. which will get me negative 3 3/4. We can think of another good number to plug in. Sam? 2. 2 minus 2 is 0. The square root of 0 is 0. 0 times a fourth is 0. And 0 minus 4 is negative a fourth, or negative 4. What's another good number to plug in? Garrett? 6. He's figuring this out because 6 minus 2 is 4, and he knows the square root of 4. The square root of 4 is 2, so this would be 1/4 times 2 minus 4. This would get me 1/4 times 2 is 2/4, which is also 1/2, minus 4, which will get me negative 3.5. You wouldn't want to go any smaller than this, because if you pick something smaller than this, you're going to get negatives under your square root. So that does kind of tell you that this is going to be your starting point. So we'll have 2 negative 4, 3 negative 3 3/4, 6 and negative 1, 2, 3.5. It's like really flat. That's okay. And then we do have our domain and range for this one too. So the domain is that x would be greater than or equal to 2. Our range would be that y is greater than or equal to negative 1, 2, 3, 4. Now put a couple stars on the last two because they're cube roots. You definitely want to do a table of values for cube roots because those are the sideways S's. Okay. And you might want to even rearrange this one. This would be minus cube root of x plus 1 plus 3. Because that'll at least tell you that it's been shifted up, down, or whatever. But I probably would do a table of values for this one because I think that's your best bet. Alright, so let's maybe start with plugging in numbers. Negative 1. Negative 1 plus 1 is 0. Cube root of 0 is 0. And 0 plus 3 is 3. Let's plug in 0. 0 plus 1 is 1. The cube root of 1 is 1, but there's a negative up front. So that's negative 1 plus 3 will be 2. I'm not going to plug in positive 1 because 1 plus 1 is 2. I don't know the cube root of 2. What other numbers do I know the cube root of? Well, I know the cube root of 8. So maybe I'll plug in 7. So the cube root, 7 plus 1 is 8. The cube root of 8 is 2. That would be negative 2 plus 3. Which will get me 1. And then let's plot those and see if we need another point. We might. Negative 1, 3. 0, 2. 7, 1. So it's probably going like this, and then up and over. If you want, you could pick another point, which would be to get negative 8 under the cube root.
Please excuse the interruption.
So you need negative 9.
Just a reminder, all vo-tech students are supposed to go to the cafeteria during periods 2 and 3 and the auditorium for 4 through 7. Again, all vo-tech students are to report to the cafeteria for periods 2 and 3, and 4 through 7 go to the auditorium. Thank you.
And if you do that correctly, you will get 5. And these ones just kind of make like a sideways continuous curve. See if you guys can try the last one. Again, creating a table of values. Domain and range for these would be all real numbers for both. because they go on forever. I'm going to pass out your homework with so you press the math button, option 4. Cube root x plus 2. Close your parentheses, minus 2. So if you were using the graphing calculator to assist you, type it in your y equals, zoom 6 will get you the picture. That's hard to copy on your paper, right? Because like, you don't know what exactly goes where. So that's when you can use your table. And the table then is created for you, so you don't have to do any math in your head. So you can see some of the points we would plot. -10, -6, that's not going to fit, I don't think. -3, -4. -2, -2. -1, 0. 6, 2. Did I plot something wrong? So this one must be going like this, and then also going down like that. Probably could have scrolled to find another value. That was. Remember that your cube root function will always look like that. Sometimes it's flipped, sometimes it's wrong.